Welcome everyone. Today we'll learn how to handle MongoDB transactions in .NET. So as a prerequisite, we need to create a MongoDB Atlas account to create a new cluster. I already have an account, so let's sign in and go to the Overview tab. Let's create a new cluster. Select the tier. I will select the free tier for demo purposes. Select all the defaults for simplicity and create the deployment. Now go to Visual Studio and create a new ASTA.NET Core Entity application. Define the name, click Nets, and create the project. Now install the required NuGet package to connect with the MongoDB instance. So I will open the Package Manager console and type install package mongodb.driver. Execute the command. Now go back to the MongoDB Atlas to get the connection string from the cluster. So in order to connect with the cluster, we need to create a database user. So define the username and also the password. Create this user and now choose a connection method. Select drivers. The .NET driver, we need to install the driver. We already installed it. So we need to copy the connection string. So the cluster is provisioning. So let's wait a couple of seconds. So now we have the connection string. So copy the value and go back to Visual Studio. Open the addSettings.json and add the connection string section and define a key for the MongoDB value. Now go to the program.cs file and add the MongoDB Setup. But before that, let's create an endpoint to create a product. So we will handle a single transaction to handle this functionality. So let's create a new post action with the product root to create a new product. So we'll receive a DTO from body. So let's create a new product in DTO class. Generate this class in a new file. Go to the DTO and we'll define a couple of properties. The first one will be the name of the product. Let's define the price. Let's add a quantity property to add a second collection, which will be called product quantity. We'll pass the ID of the product and the quantity or the elements for the product. And finally, we'll add a new list of a stream, which will receive a base64 images. Will simulate a connection with a storage service, and this storage service will return the URLs from these base64 images. So go back and now define the body of this endpoint. Let's establish the connection with MongoDB. So add a new property called client, call the Mongo client class and pass the connection string. So access the iConfiguration interface to get the connection string. Go to the add settings and copy the name of the key. Now access the database from MongoDB. So call client.getDatabase will create a shop database and a product collection. So go back to MongoDB Atlas, close this connection, click database in the deployment tab and click browse collections. Create a new database with the shop name and a collection name. We will define product collection, so click create. Now go back to Visual Studio. Let's create a new collection through code. Let's call db.create collection asynchronously. So that's why I added the await keyword, and let's define the name. This collection will be called as product inventory. We'll create the collection outside a transaction because it's not possible to create collections in a transaction. Now let's access the two collections. So create two variables. The first one will be products. So call db.get collection. We need to define the type of the collection. So we'll create a class product and pass the name of the collection and a second collection for the products inventory. So we'll define a new class called product inventory and specify the name, add or generate a new class in a new file. So go to the product class And this collection will contain a couple of properties. The first one will be the ID. Add an attribute to define the JSON representation for the object ID that comes from MongoDB. So the representation for this object ID will be this string ID. Let's define the remaining properties, the name, the price, and finally a list of images. Let me copy this ID property and now go back to the program.cs file. Let's generate the product inventory class. Navigate to the file. So this product inventory will contain the ID and the quantity. So let's define a quantity property. Go back. Now it's time to perform a transaction. So a transaction allows us to perform multiple operations that don't change any data until the transaction is committed. In MongoDB, transactions are performed within sessions. So let's create a new session from the client. So let's create a new variable called session. We'll use this using to dispose all the unmanaged resources. So call client that start session asynchronously. So let me add the await keyword. And from the session, we'll start a new transaction. And now let's define a try catch blocks to handle exceptions. In the try block, we'll perform or we'll add the product creation logic. So let's start by creating a new product in the collection. So create a new instance of the product class, defining the name. So we'll get the name and the price from the DTO from body from this post action, and call the products collection and insert this product. Here it's important to specify the session in the MongoDB operation. We will add this session in all the MongoDB operations to specify that we're performing a single transaction. Now let's create a new product inventory document in the product inventory collection, so called products inventory, and insert want. We define the session and create a new product inventory object with the ID, which will be the ID of the new product, and the quantity from the DTO. Now let's suppose that we have an external dependency with a storage service to upload the base64 images and to get the URLs. So let's imagine that we get the images from a new storage service class from an upload images method. So we'll pass the base64 images and get the URLs. So let's create a new class. You can apply dependency injection, but for simplicity, I will create a new instance of our storage service. So generate the class in a new file and create the method in this class. Go to the upload images, and this method will return a list of URLs. And let's simulate that we'll return a URL from an image. Go back. So we'll set the images into the product collection, and then we'll update the product. So we'll use the replace one async method. So call the products collection and use this method. We define the session. We need to define the filter. So we'll add a lambda expression to specify that we will replace the document when the ID is equal to the product ID. And finally, we will pass the product. And finally, we need to commit the transaction. So call session at the await keyword and call commit transaction asynchronously. And in case we have an exception, we'll abort transaction. So in the catch block, we'll call session that abort transaction if any unhandled exception occurs during a transaction, and we'll return a bad request in the endpoint with the exception message. So if the transaction is committed, we'll return an OK status code with the new product. So we define the whole transaction. Now it's time to test this endpoint, run the minimal API. Let's copy the API URL. In Postman, we'll test this endpoint. So let's copy the URL and define the product root and the post action. So we'll pass the body in JSON format with the name, price, quantity, and base64 images. Let's send request to the API. So go to the .NET application and add a breakpoint in the try statement, send request. So we establish the connection with the cluster. We'll get the database. We'll create a new collection called product inventory. We'll get the collections and we start a transaction. So we'll create a new product. Then we'll insert the product. The client can see the changes at runtime until the transaction is committed. As you will see, the ID is set. So we'll add a product inventory document in this collection, and then we'll simulate a connection with the external dependency to upload the images and get the URLs. So we get the images, we set these images in the product, and we'll replace the document in the collection. And finally, we'll commit the transaction to perform or to execute all the operations that we define in this creation product logic. And finally, we'll return an OK status code with the product details. So go to MongoDB Atlas. Let me open the collections again. So in the shop database, we have the new product inventory collection, and we have the product collection. Let's see if the transaction was successful. As you will see, the product is created, and similarly for the product inventory. So the transaction was performed successfully. Now let's simulate a failure in the storage service connection. So in the API, let's go to the upload images section and let's throw an exception. There is a timeout in the connection. So let's add this message and go back to the program.cs file. Let me remove this breakpoint and run the minimal API. Let's add a breakpoint in the catch block. Go to Postman and create a new product with different values and send the request. As you will see, the endpoint will throw an exception due to this storage service failure. So we'll abort the transaction. So let's continue and we'll return a bad request in the action with the message connection timeout. So go to MongoDB Atlas and you will see that in the collections, the transaction was aborted. So we had just one product and one product inventory document. So the transaction was aborted. We don't perform any operation in the minimal API. So in this demo, we've learned how to handle MongoDB transactions in .NET.